This protocol we are going to start is a very popular protocol. Open shortest path first. Now, this is a routing protocol which is widely seen not only in enterprises, also in service provider. This is a link state. Link state routing protocol. Link state routing protocol. We learned EIGRP as a advanced distance vector protocol. RIP is a distance vector protocol. EIGRP is an advanced distance vector routing protocol. OSPF is a link state routing protocol. OSPF advertises link state information, link status information that helps the routers to know about the complete connected links, the complete topology. It advertises the link status, like link, whether it is up or down, what network is configured on the link, what mask is configured for the IP address on the link, what is the bandwidth on the link, all this information. What area this link belong to? Yes, OSPF have got areas. We put router in a group and we call that group with one number and we call it as area ID. So what area this router belong to, what area the link belong to, all this info are advertised. By gathering all the advertised link state information from various routers, this router can build the complete topology in its database. Every router builds complete database of the topology. That's why this protocol, we call it as link state routing protocol. See, when you take a EIGRP, there is no link state advertised. Only the routing table is advertised. Whatever this router knows as best, it will advertise to the next router. It's like you want to go somewhere, you ask on the roadside how to go there. The person will give you the answer which he knows as the best. But there may be many other routes to go to the destination which you will never learn. But when you take a map and see, you will be able to see all possible paths to the destination that you want to go. So using map to find the path is better than asking someone on the roadside. If you ask the auto guys, they will tell you the road that is best for autos. But you are going by walk. You may have a better, shortest path than going that road given by the auto guy, the tuk-tuk guy. So Instead of using the tok information, you use a map. That's better for you. You will have multiple choice to pick same way. OSPF advertises the link information from every router to all other routers. That helps to collect and form a big map using which this protocol can pick the best path and give the best path to the routing table. The route that is there in the routing table will now be used for packet forwarding. That's why it is called as link state routing protocol. It's purely based on the link state advertisement. The routes are determined. Definitely they will ask you this question in interview. After 8 minutes spending on this, don't expect another day to explain interview question of what is link state. You should keep this in mind. You should write it down. Now, open shortest path first is a link state routing protocol. Like all other protocol, OSPF also have got administrative distance. Can anyone tell me what is the administrative distance of RIP? What is the administrative distance of RIP? 120 is for RIP. For EAGRP, we saw 90. Yeah? That's for internal. Okay. For OSPF, it is 110. It's 110 for OSPF. So if I will be running a router with OSPF and EIGRP, EIGRP says to go to 1.1.1.1, go straight. OSPF says to go to 1.1.1, go this way. Which one do you think this router A will follow? Will it take the green path or the orange path? Exactly. Orange. The lower the administrative distance, better is the route. EAGRP is only 90 administrative distance. OSPF is 110. Okay, so that's the use of administrative distance. These are all really important question for interview. Why do we need administrative distance? Your answer should be when we are running more than one routing protocol in a router. If both the routing protocol provides a route for a destination, a router cannot use both. Router has to accept once and ignore the other one. Based on the administrative distance, it decides. The routing protocol whose administrative distance is lower, given route will be preferred. Are you clear? All right. Administrative distance is 110. Now what about the metric? Metric of OSPF is only one. We call it as cost. Cost is the metric in OSPF cost. You can specify a cost. If you don't specify, there is auto cost. Automatically, it will calculate the cost based on bandwidth. Based on the bandwidth, it will decide the cost. You can specify if you want to specify a cost. Cost is a number. I like this path, I don't like that path. Then what I'll do? I'll give small cost to this path which I like. So the packet will be forwarded on that path. You can do like that. But most of the time people don't do that. They leave it auto. So OSPF will decide based on the bandwidth. The one with the more bandwidth will have less cost. Less cost paths are always best paths. Cost is automatically calculated based on bandwidth. For example, when you have a link of 10 meg, another link of 100 meg, the cost will be definitely different. If you don't set cost, it is going to be like this: 100 divided by the bandwidth. What is the bandwidth here? 10. So 100 by 10 is 10. Next, 100 divided by bandwidth. What is the bandwidth here? 100. So what is the cost? 1. So packet will be forwarded over this path rather than the other one. Lower the cost, better is the route. Right. So when you don't set cost, this is how it is calculated: 100 by the bandwidth. So far what we have seen is open shortest path first is what OSPF stands for. Next what we saw is it is a link state routing protocol, and we also learned why. And thirdly what we saw is we saw the administrative distance is 110. Administrative distance is important when we have more than one routing protocol on the same router. Fourthly, we have seen the metric of OSPF is cost. Metric of OSPF is cost. And if you don't specify cost, automatically cost is calculated. It is called as auto cost. Auto cost is based on the bandwidth on the link, and the formula is 100 by the bandwidth. Done. Next, OSPF. O stands for open. What is that open? It's an open standard routing protocol. Open standard routing protocol. SPF is an algorithm which is used in this OSPF. Understand this very well. SPF is not a routing protocol. SPF is an algorithm that is different. But this routing protocol OSPF is built using this SPF. That's why the name OSPF has come. It is open standard routing protocol. What is open standard? What is open standard? Open standard means anyone can use it. No one is the owner for it. It's an open standard. And this routing protocol uses SPF algorithm. SPF. SPF is an algorithm which is also called as binary tree algorithm. You might have heard this in your college days. Binary tree algorithm or SPF algorithm or Dijkstra's algorithm. Dijkstra is a name of a man, Dijkstra. Let me show you. This SPF algorithm, even though it was designed by Dijkstra, he made it as open standard. So we see in various places SPF algorithm in use. Routing protocol OSPF also uses the same algorithm what the Microsoft operating system uses, Intel processor uses. Yeah, so SPF is not a routing protocol. OSPF is the routing protocol. SPF is an algorithm used. All right. So OSPF is a routing protocol. OSPF is a routing protocol. SPF is just an algorithm used there. So Dijkstra has got no connection to this OSPF routing protocol. Has got no connection, no direct connection. OSPF is an industry standard routing protocol. All right. Now we have seen metric, we have seen administrative distance, we have seen what type of protocol it is. It's a link state routing protocol. Now, how big the network it can support? Unlimited. OSPF unlimited. Unlimited routers, unlimited hops, unlimited hop count support. How is that possible? It is possible because OSPF follows a hierarchical design. You will have group of routers called as backbone, and you got again another group of routers non-backbone. Like this, you will have many non-backbone areas. Many non-backbone areas. So this design, makes this OSPF highly scalable. Makes this highly scalable. So, you may have plenty of routers inside, like 200, 300 routers. Here also you have 200, 300 routers. Likewise, here, here. You got many of them. And to connect between these areas, you have a backbone area. Right, because of this hierarchical design, OSPF is highly scalable. OSPF is highly scalable because it follows this two-tier architecture. Many areas, how many? As many as you want, you can have. Each route is an area. And to connect all this non-backbone area, you have one backbone area. This is what called as backbone area. Backbone area. To identify this backbone area, number 0 is reserved. Area 0 means backbone. It is always 0. You cannot use any other number as a backbone. Area 0 is a backbone. And if area 1 wants to share any updates to area 2 or area 3 or area 4, it is only through area 0 it can do it. Area 1, even if I have a wire connected like this, they will not form neighbor. Why? This port belongs to area 1 and this port belongs to area 2. If area ID is not matching, they don't form neighbor. They don't form neighbor. So it is only through area 0 the updates go. You see, this router is in the border. This port belongs to area 1. In this router, this port belongs to area 1, so they form neighbor. And this port belongs to area 0. This port belongs to area 0, so they form neighbor. We call this type of router as area border router. Area border router, ABR. These are non-backbone area routers. They are internal routers to area 1 or area 2 or area 3 or area 4. But this router is a backbone router. Whereas this is a area border router. It has got special name, area border router. This has got backbone router. This is internal to non-backbone area. You can say non-backbone area router. This hierarchy design makes OSPF a highly scalable, supporting large environment. Okay, so OSPF is a highly scalable routing protocol. That is the reason why it is used in various places. Enterprises, service providers, usually service providers are very big networks because they provide internet connection to various big companies. So service providers are very big network. Even there you can see OSPF. Highly scalable. Fine. So when you configure OSPF, you will be mentioning area ID. That is to say, to which area that link belong to. If you take ABR, this link belongs to area 0. Whereas on the same router, this link belongs to area 1. So you have to mention which link is in which area. That's why you need area ID. Area ID is a number again. You have 32 bit for area ID. You have how many bits for area ID? 32 bit. This all can be an interview question. So area ID is a number that we give to tell what area that link on the router belong to. You may have all the links in same area. For example, this router, all the links are in same area. But on this router, one link is in area 0, another link is in area 1. That's why that is called as ABR, area border router. We have area ID. Not only that, we have router ID. We just saw what is area ID. We also have router ID. What is a router ID? It is like a name given to a person. If there is a group of students in a class, one person name is Tangaya. If another person name is also Tangaya, there will be a confusion, no? Then we will not know who gave this, which person. Both are Tangaya. Confusion. See, the routers need to advertise the link state information. If two routers have got same router ID, then problem. Then the receiving router will not know which one gave this update. So every router has got unique router ID. Not only that, this router ID only helps to avoid loop. Say for example, Priya is the ID for a router. Priya is advertising something to Pavitra. Pavitra is giving to me. And now I am giving to Priya. Priya will not accept it. Why? Because in that update, her name is there as the originator. She rejects it so that loop can be prevented. If she accepts, then loop will occur because it's her own update coming through me. She sent to you, Pavitra, but it is coming through me to her back, which is loop. So router ID helps to avoid loop because there is a name written in that update, Priya. Priya won't take it. The name is important. If the name is not there, she would have taken it and formed a loop. So every router has got a name, a unique name. That name is what called as router ID. And that unique name, that router ID, is also in the format of IP address. It'll, for look and all, it will be same like IP address. 32-bit. Router ID is what? 32-bit. So you can assign a router ID by using this command router ID 1.1.1.1. You can give any address as a router ID. Even if this address is not there in the router, you can give. Hello. Do you understand? Even if this address is not on that router, you can give it as a ID because it's just a name. It is just an ID. Now, if you don't configure, this is the first preference. If you don't configure, it will take the biggest IP address that you have configured on the loopback interface. What interface? Loopback. Yesterday I told you there are various use cases of loopback interface. So this is another use case. OSPF will pick a name as the router ID from the loopback interface. If you have more than one loopback interface, the biggest IP address among those two, among those loopback interface, will be taken as the router ID. See, the first thing is it will check whether you configured manually. If not, only this option. What if both are not there? You also did not configure. Loopback interface is also not there. Then it is going to pick the biggest IP address from physical active interface. You understood? Physical active interface. Interface should be up. It cannot be shut down. It should be up. And it needs to have an IP address. That IP address will be taken as the router ID. So remember, every router needs an unique ID so that when they send the update, they can put the ID and send to others to know who sent it. And this ID should not be duplicate, should not be with any other router. It's only one ID for one router. It should be unique. We can configure. If you don't configure, it is going to pick the highest IP address from the loopback interface. If loopback interface also do not have an IP address, or you don't have a loopback interface, then it is going to pick the highest IP address from the active physical interface. Is that clear? Did you understand? Okay. Today